Hello, everyone, and welcome to another episode of Echo Live. My name is Paulette, and I will be sort of facilitating our program today. If this is the first time joining us, or if you've joined us before, go ahead and introduce yourselves in the chat feature. That chat feature is how I'm going to be interacting with you throughout our program today. So I'll interact with you, I'll ask questions, you can answer them in the chat. So just so I can get to know a little bit about who's watching, go ahead and put your name or where you're from, especially because of what we're talking about today. Today, we're going to be talking a little bit about the Aurora Borealis, or the Northern Lights. This is one of my favorite topics to talk about, and that's because the Northern Lights are very special to me. I actually took a trip about 3 years ago this week to go to Alaska to see the Northern Lights in person, and it was an amazing trip. So what you can see behind me in our virtual background in our Echo Distance Learning Studio is that we can see some of those Aurora Borealis happening. Now, this is actually a time lapse. The aurora don't move quite this quickly, but you can see them move over time if you go outside and you watch them. Has anyone that is watching today, have you ever seen the Aurora Borealis or the Northern Lights before? Go ahead and answer that in the chat if you have. And like I said, I've seen the Northern Lights a few times. I have seen it in Alaska about 3 years ago. And then I saw the Aurora Borealis when I was in college. So that was quite a few years ago. And then I actually saw the Aurora Borealis when I was a kid. Now, if you're from northern latitudes, like a little bit further north than Detroit, you'll probably see them a little more often. For example, I grew up outside of Madison in Wisconsin. So I grew up, of course, in the middle of nowhere. We were able to see a lot more up in our nighttime sky. I was very, very lucky. And I was also able to, like I said, see the Aurora Borealis a couple of times. I went to school a little bit further north in Wisconsin, in Stevens Point. And so I was able to see them there as well. But if any of our friends are up in the Upper Peninsula of Michigan, you've probably seen them quite a few times. And if we have anyone joining us from the northern latitudes, you get to see them a little bit more often. Now, if you're like our friend Evan from Texas, you might not actually be able to see them from lower latitudes. And we'll talk about why in just a little bit. So for those of you that are just joining us, we're talking a little bit about the Aurora Borealis or the Northern Lights. And the Northern Lights are something, like I said, that's very special and near and dear to me. So today, we're going to talk a little bit about why these aurora happen. So we're going to talk a little bit about what's happening in space and then what's happening in the upper part of our atmosphere to actually create these lights that we see. Oh, so we have a friend joining us from Cadillac, Michigan, in northern Michigan. You probably have seen the Northern Lights before, but like I said, the further north you go, the better they are. So we'll talk a little bit about why we see these aurora. Now, we have our handy dandy fun sun right here. These are our celestial buddies that are joining us today. So we have our sun and we have the earth. Now, the sun and the earth orbits around the sun. We live pretty harmoniously together. The sun gives us our light and gives us the energy for plants to survive, and for life to be able to survive on our planet Earth. So the sun is very, very important to us. But the sun is also super, super dangerous. So the sun is constantly blowing off gas. So it's blowing off these electrically charged particles all the time, and that's really dangerous. It's a form of radiation that can actually be really dangerous to people if they're like traveling in space. It's one of the issues that we have when we're talking about traveling to the planet Mars. So here we have our sun, and our sun is blowing off these electrically charged particles all the time. It's something that we call the solar wind. Now that solar wind, though it's really dangerous, actually doesn't really affect us much here on the Earth. So we're right here on the Earth, and the Earth has something called a magnetosphere. So it has a giant magnetic field that goes around it, kind of like this. It comes out from the top and goes back in the bottom. So it has a huge magnetic field around us. Now, if you've ever used a compass before, you might have actually used that magnetic field that's around the Earth, because we actually use things like compasses to find magnetic north by using that giant invisible magnetosphere or magnetic field around it. So we can actually use a piece of metal slightly magnetized, and it will follow our magnetic field, and that's how compasses work. So here on the Earth, we have that giant magnetosphere to keep us safe from the solar wind. For the most part, these electrically charged particles, and we've talked about this on Echo Live before, those electrically charged particles and magnetic fields are very similar. We call that electricity and magnetism for a reason. They sort of work together. So for the most part, those electrically charged particles are bouncing off of our magnetosphere and just leaving us alone. Some of those charged particles will actually move in and come into the northern pole or the southern pole down here. But for the most part, the solar wind kind of leaves us alone because of those that magnetic field that we have surrounding the Earth. So we have our Earth with our magnetosphere around it. Now, not just the sun, it doesn't just give off a stream of electrically charged particles. Sometimes the sun will actually throw off or burp off giant streams of electrically charged particles. We call those coronal mass ejections. Now, there are a couple of different things. There's coronal mass ejections are when the sun is blowing off a lot of electrically charged particles. There's also some smaller versions of those as well. But when those coronal mass ejections, as the sun rotates on its axis, if they're pointed in the direction of the Earth, it'll actually peel back some of our magnetic field. So coronal mass ejections can be really, really dangerous to us on the Earth because we use magnetic fields to deal with compasses, but we also use magnetic fields for our GPS. We use magnetic fields for a lot of things out in space, as well as it actually can cause some electricity in our atmosphere, and it can take out entire electrical grids. So we've actually had coronal mass ejections take out entire electrical grids in places in Canada in the relatively recent past. So coronal mass ejections can be really dangerous for us, but if they're small enough, those coronal mass ejections will actually produce the Aurora Borealis that we see. So what happens is the burps from the sun, those coronal mass ejections will come in and they'll meet our magnetosphere. When they do that, it will be they will actually pull away some of our magnetic field, but we still have some magnetic field which keeps us safe. And it will actually, the particles, these electrically charged particles, will follow our magnetic field and enter the Earth's atmosphere from the top or from the bottom. So you might have heard of Aurora Borealis. Aurora Borealis are the northern lights, but you might not know that there are also Aurora Australis. So those are the southern lights. So there's Aurora Borealis, the northern lights, and Aurora Australis, the southern lights. So we can actually see these northern lights and these southern lights from basically when we're talking about the top part of the Earth. So the stronger the coronal mass ejection, the further down we'll be able to see the northern lights. So if we have a really, really strong coronal mass ejection, let's find the US, right? Yes, that's the US. Okay, North America right here. So we've got North America, and here we have our North Pole. When these coronal mass ejections are strong enough, well, most of the time we see them right here, sort of in the Arctic Circle or north of the Arctic Circle. But the stronger the coronal mass ejection or the stronger the solar event, the further down they go. So here in Detroit, we've actually been able to see Aurora Borealis from our location and our latitude relatively recently. Unfortunately, we have a lot of city lights around us that make it really hard for us to see the northern lights. Best case scenario when you're trying to find the northern lights is to go out and be away from the city lights, like most astronomical viewing. But there actually have been cases where we've been able to see the northern lights in Mexico. So those coronal mass ejections are pushing that line of Aurora Borealis super, super far south. So we're actually even able to see them in Mexico. Now that I don't believe that has happened in my lifetime, but that must have been a huge, huge solar event that happened. So yes, we have our Aurora Borealis and our Aurora Australis that we're able to see. Now, what's actually happening when these solar events are interacting with the Earth's atmosphere? Now, in the past, we have talked about something called plasma. Does anyone remember us talking about plasma during some of our other programs? Plasma is our fourth state of matter. We have solids, things that are basically at rest. The molecules inside of them are shaking like this, just like this. They're not stopped completely, but they're not really moving around very much. And then we have our liquids. Our molecules are able to freely move in a liquid form. And they kind of dance around like this. This is I call this the states of matter dance. A lot of fun to actually do. So if you want to do this at home, remember you're solid, you're a liquid, and then if you're a gas, you have so much energy that you're running around the room. You're running around the room, running around the room. If you're a gas, then you are all over the place. You fill the container that you are inside of. If I were to pop a balloon in this room with helium in it, then helium would go everywhere and go to every single corner of the room. So we have our three states of matter that we know about for the most part. We have also our fourth state of matter, which is plasma. So when we take a gas and we add electrical energy to that, what we do is we actually strip off some of the electrons from that electrical energy, like what we have inside of here with that electrical energy. We strip off the electrons and we create something called a plasma. This right here is a plasma globe. So we have a gas inside of here and a Tesla coil inside that's electrically charging the gas that's inside of here. It's actually neon gas that's in here. So we have sort of our electrically charged particles or our plasma inside of here, right? All right, so what does this look like inside of our plasma globe right there? Tell me, what does that look like to you? It might look like something that we see naturally occurring on the planet Earth. To me, it kind of looks a little bit like lightning. And lightning is that naturally occurring form of plasma. So here we have our naturally occurring form of plasma, lightning inside of here, but the Aurora Borealis is also a naturally occurring form of plasma. Now, plasma glows. And so we can see that with our globe right here. I have to be standing in front of it for us to be able to see it. But we can also see it when we talk about some of the things that we have seen in Echo Live in the past. So our friend Anna has actually talked about plasma before. She's talked to us about what we can see. There we go. She's talked about plasma, what we can see when we look at different gases inside of these tubes. So let's go ahead and see what Anna had to say.
Now this is basically just a housing that we can...
Let me double check to make sure I shared my computer sound. There we go. So let's go ahead and see what Anna has to say.
Put different tubes of gases inside of and take a look at what colors we see emitted by those specific gases. So krypton was one of those gases that we find on the periodic table, and we saw from our plasma globe that that burns a bright purple. But let's take a look at some other elements. Let's first look at hydrogen, which is element number 1 on our periodic table. We talked about how hydrogen makes up almost 90% of our sun. So we might know what hydrogen looks like. We'll go ahead and we'll turn on the power, which is going to send electricity through that glass bulb, which is vacuum sealed with only hydrogen gas inside. And let's take a look at what color that gas ionizes to. All right. So we see a pretty interesting color change here. We see that this gas burns kind of a bright purple color, at least to our visible eye. But what's interesting about these spectrum tubes is even though we observe this kind of bluish purple color, this is really the final product of a few different wavelengths of light. Almost.
All right, so that was during our pajama day, wear your pajamas to work. So we were able to talk a little bit about plasma and visible light on our program. Now, for those of you that don't know, all of our Echo Live programs are saved on our YouTube page, as well as our Facebook page. So if you wanted to go back and view them later, you absolutely could. That plasma, she's talking about how it shines different colors. Now we're going to go ahead and take a look at some Aurora Borealis. We're going to see what colors are in those aurora. So taking a look at some of these images that we have here, what are some of the colors that we see in those lights? What are some of the colors that we see in the lights? We might see some greens. We might see some purples and some blues. We might see some reds. There's all sorts of different colors that we see in those Aurora Borealis. So what's happening is though that light or those electrically charged particles are actually coming into our atmosphere and they're charging up the gas in our atmosphere. What's one of the most abundant gases in our atmosphere? If you've been watching Echo Live for a while, you might remember this. What's one of the most abundant gases in our atmosphere? If you've watched our episodes before, maybe if you watched on Tuesday, you might have seen us use this to make ice cream. One of the most abundant gases in our atmosphere is nitrogen. And nitrogen, when it gets all electrically charged and excited, it gives us that green color that we're seeing. Another gas that we have in our atmosphere is the one that we breathe, oxygen. We also have oxygen in our atmosphere. So that oxygen will get super, super excited and it'll start to glow sort of a bluish color. There might also be some yellow in there as well. So all of these different colors that we see are actually caused by different gases in our atmosphere. So it's all the same stuff coming from the sun. It's just different gases that are interacting with it. So when we start to see the red ones, when we start to see red Aurora Borealis or northern lights, we actually start to see those further down in latitude. So in the northern part, the the particles from the sun are not particularly energetic. So they're able to just reach the upper parts of our atmosphere where we have a lot of N2 or O2. But the further down that it gets, the more we're starting to see it interact with other particles and actually pull off those particles from each other. Nitrogen and oxygen are narcissists. They love themselves. They like to stick together in groups of two. But when we start to pull those two apart and make an even different ionized molecule, O1, we're actually starting to see those ionized molecules giving off different colors because they are not necessarily attached to each other anymore. So the further down we go into our atmosphere, the more energy they need to form these Aurora Borealis. So we're starting to see molecules actually being ripped apart into its parts. And so we're starting to see some different colors further down. So one of the really weird and eerie things that has happened in the past is these Aurora Borealis. These have actually been sort of in a history for a long time. We've talked a little bit in our Echo Live programs about astrology, especially when we were talking to Christian, our CEO. So in astrology, they would see these northern lights and think that they were pretty cool. But when they got down to where like Greece and that area, they were blood red when they looked up into the sky. So the lights across the sky were blood red. And I don't know about you, but that would freak me out if I saw things up in the sky, if the whole sky turned blood red. And so they started making stories up about these Aurora Borealis and what they meant. And so blood red Aurora Borealis were actually a really, really bad omen. But I think they're really super cool. I think that red Aurora are some of the most unique ones that you can see. And I think they're fascinating, even though they might be a little more dangerous to our satellites and our electrical grids. I still think they're pretty awesome. All right. So we don't just see the aurora from the Earth. We can actually see these aurora from space as well. So we're going to go ahead and watch a quick video of the aurora when they're on the International Space Station. Let's see. We're still going to take a quick look at it, but let me go ahead and try and find it in our browser instead. So the video that I'm about to show you is actually from NASA. IFS. So this is actually, this one's actually a European Space Agency video. So I'm gonna go ahead and share my screen with you for our browser instead. That might be a little bit easier and might work a little bit better. Sometimes we use PowerPoint for some of our stuff and it can be a little bit weird and wonky. So here we go. We can see the aurora from space. So this is actually from the International Space Station. And you see these astronauts are moving very, very quickly. They orbit around the Earth every 90 minutes. They're actually able to see these electrically charged particles up in the upper part of our atmosphere glowing. Notice it isn't near the ground. It's pretty far up into space. And for the most part, these electrically charged particles will be a circle around around the North Pole. So normally we'll see the Aurora Borealis from space just right around here. And like I said, that line tends to go further down the more energy the sun will burp off or give us. So we have our Aurora Borealis, and they are some of my favorite things to see. Now, a really great resource to be able to tell whether or not you're going to be able to see the Aurora Borealis is going to the NOAA, the National Observatory for Atmospheric. The NOAA, they will be able to tell you. So that's who we use for weather and stuff like that. We track hurricanes with the NOAA, but they also track something called space weather. So if you Google NOAA and space weather, it'll actually take you to their space weather website. On their space weather website, you will be able to see a few different things. You'll be able to see what the sun is doing right now, and you'll be able to see something called the Aurora Circle as well. So let me go ahead and share my screen with you so that you can see what I'm seeing on the NOAA website. So this is something that you can go onto at home. So it's the National Oceanic and Atmospheric Administration. I've got so many different different things like NOAA, NASA, that kind of stuff in my head that sometimes I forget. So it's the National Oceanic and Atmospheric Administration. And this will actually tell us what our solar weather is like. So right now, our sun is kind of lame. It has the solar wind blowing off of it, but we aren't really seeing much activity happening. It will also tell us activity that we might be able to see in the future as well. But right now, pretty slow. When there is an event, it'll actually show up on here as different colors. So when there is an event, you won't see green, you might see yellow or red instead. Now we can also see this Aurora Forecast. This is one of my favorite things to take a look at because it actually shows you the probability of whether or not you'll be able to see an aurora. So you can see that this probability is actually really low right now because, again, the sun isn't really doing very much, and you have to be really high in the United States to be able to see even a 10% of a chance to be able to see the aurora. But I do encourage you, if you have the chance, if you ever see anything in the news that there might be a coronal mass ejection coming our way, try and check out the Northern Lights. And if you have a chance to go visit Alaska, I highly recommend it. Or anywhere here above sort of that Arctic circle, you're fairly likely to see the Aurora Borealis. You're more likely to see them around the equinox, which is our time that we have right now. We're starting fall pretty soon. And you're able to see them around the spring and fall equinox, so when spring and fall start. But I definitely encourage you to go outside, try and find these Aurora Borealis if there's a coronal event. This isn't something that you'll be able to see just on a regular night outside, unless maybe you live up in the Upper Peninsula. You might see them a little more often than we do down here in Detroit. So if anyone has any questions, definitely type those questions into the chat. And thank you, Evan, for giving me some help with the National Oceanic and Atmospheric Observatory. I appreciate when people give me some help. So if you have any questions, go ahead and put those in the chat. This is, of course, a perfect time to thank our sponsors, Ford and Denso. They have been sponsors throughout our entire program. And I mentioned that the fall equinox is right around the corner. The fall equinox is actually on the 22nd of September. So right now we're on our summer schedule where we've been visiting you in your homes on Tuesdays and Thursdays. But starting next week after our fall equinox, we're going to be only visiting you on Wednesdays. Since most of you are back in school, we still want to be able to see everybody every week. We love having you join us. So we'll still be doing Wednesdays at dentist hour, 2:30. But we're going to be breaking that down to just Wednesdays instead of Tuesdays and Thursdays, so that we can still do even more programming, maybe outside of our Echo schedule. But it's been great seeing everybody every single week. Next week on Wednesday at 2:30, we're going to be talking about the fall equinox and a little bit about some of the really cool things that NASA and other space agencies have been finding in right now. You might have heard some news about Venus, so we'll be talking about that next week as well. So our fall schedule will be Wednesdays at 2:30 p.m. Eastern time. We have been so happy to see everybody every single week, and we hope that you continue with us on Wednesdays, 2:30. Even though I know most of you are back at school, we're just really happy to see everybody every single week. So thank you so much for joining us today. Not seeing any questions other than yay science, because science is amazing. Thank you, Evan and Justin. I love science as well. If you have any other questions, feel free to put them in the chat. We'll check it after the video, after everything has closed up. But thank you so much for joining us, and we will see you next time.